right, so hello everyone. My name is Jaci Carithers.
I'm Samantha Gowen.
And we are both third-year medical students from PCOM, Georgia, from the Suwanee, Georgia campus. And today we'd like to present to you our presentation on lead contamination propagation to plants of a Metro Atlanta home. I know of many patients that wish to have their own vegetable garden to grow from, or if they live in the city, community gardens to have access to, such as this person here, or our patient rather, had this lovely terrace garden in her backyard. And one day, though, she realized, oh, I'm finding a lot of these hard coal-like substances in my yard. I wonder what they are. And so she sent them in, and it turns out they were slag, which is a byproduct of mineral ore smelting. And in this case, when she sent the samples off to the EPA, it turned out to be lead. And the lead contamination was significant enough to warrant further evaluation. We found from research in the area, and we theorized that her property at one point used to be part of a railroad easement, where at one point they were disposing of their manufacturing waste in that area. So when it comes to lead and what's considered normal or abnormal, we have this infographic created by the EPA. And when it comes to levels of 0 to 100, and we usually refer to milligrams per kilogram, but it's a 1-to-1 equivalent to parts per million. It's stated that it's safe to garden with children and all food crops are safe. This is also considered the background level range when it comes to the naturally occurring lead found in soil. For the United States, on average, it's about 26 milligrams per kilogram. For the state of Georgia, where this research is based out of, it's about 13, and for Alabama, about 14. And it can vary from region to region as far as how much metals will be within the soil or chemicals naturally found. And if you live near a lead mining site, higher, and if you don't, lower. When it comes to beyond 100 and forward is when we worry about exogenous sources of lead in our environment. And especially in the case at the 400 level, the EPA has stated at this level that majority of research shows that children are likely to have lead contamination or poisoning when they've done their research there. And at this point, it's safe to say that no amount of lead is safe to have in children. And the standards have varied. Previous to 2012, it used to be okay to say 10 micrograms per deciliter. As of 2012, after it was 5. And then as of 2021, it's now 3.5. The same thing happened again with soil lead contamination in that in 2021, the EPA stated, no, 400 is not a level that contamination can occur. It's actually about 200 milligrams per kilogram. So they do say, keep your children out of the garden, do not grow root crops. And at this point, it's still safe to say, grow fruiting vegetables or legumes and such. Beyond 400 is when they say, again, keep children out, do not grow root crops, but then also any form of vegetation coming in contact with the soil. It's best to say that it's highly unlikely you're going to clean off all of the soil from it. So probably avoid using those type of vegetation. And then from 1,000 onward, they make the standard of do not garden directly in the soil and grow all crops in raised beds. And someone would probably think, well, why are you still using this property for gardening? And unfortunately, we do live in a society where it's kind of impossible to relocate at times. And so to help mitigate this factor, they did state that growing in, where'd my cursor go? Growing your crops in a raised bed where you import in new uncontaminated soil is sufficient. And as long as you have a barrier between that and the soil below, you should be fine. So now this is from the EPA talking about soil, but what about the vegetation growing in there? And so our research was to see if significant levels of lead may be propagated from the soil into the vegetation and what could be the effect if consuming that might be an issue. And in some cases, some plants are considered hyperaccumulators. For some reason, they naturally like to incorporate lead into their system. Figure 1 shows an EPA aerial map of the soil testing in 2022. The reason for these terraces, well, I gave the answer already. The reason for why they have it in this kind of manner is because this is a terraced garden. And we tried our best to match the zoning areas for our research. Figures 2A and 2B show the before and after when the patient realized that her soil was contaminated. And figure 2A in 2020 showed all of her vegetables, whereas when we came to the property in 2023, there wasn't that many. So that limited our ability to test vegetables that we'd consume. And instead we focused on ivy, ferns, and whatever plants were available that would fit in a 1 gallon size bag. What we then did is when we collected the plant, we tried our best to collect the soil into a 1 quart size bag, as you see in figure 3A. And from there started our lovely processing where we delved into some environmental sciences here. We dehydrated the plant and soil samples. We checked the weights pre and post just to see how much water evaporated out. And then from there, in order to analyze through ICP mass spectrometry, we ground the samples with ceramic grinders as well as mortar and pestle. We analyzed our soil samples in triplicate to help with statistically significant results to obtain there. And with the plants, though, unfortunately, with especially the ivy, we did not have sufficient biomass to be able to perform triplicate. So unfortunately, we would just grind those samples down and submit those for ICP mass spectrometry.
So the samples we picked are from sites 1, 3, and 7. And those are because 1 and 3 are that front part of the garden, and then site 7 is on the posterior side of her garden. Another thing too to keep in mind is that site 3 was on one of the down slopes of this terrace, so it was somewhat used, but it wasn't as used as much as the site 1. So for our results, what we did is we took figure 4 shows the soil analysis, and so you can see here is that source sites 1C, 3B, 3C, and 7B showed significantly elevated levels of lead compared to the counterparts. And then table 1 shows standard deviation and confidence intervals for those samples. And then figure 5 shows the concentration in the plant samples. And these were, each plant was run, like we took one plant and then we would run that triplicate, but we couldn't have 3 samples from one plant to run those triplicate, if that makes sense. And so you can see here is that 7C is significantly higher compared to the others. And part of what can contribute to that is the location of the plant. In that 7 part of that figure, you can see what happened is that plant was located underneath the balcony of this the homeowner's house. And so it wasn't as exposed to the elements compared to the other samples. And as a result, it could have accumulated more, as well as we know that the pH of the soil influences whether or not lead is accumulated within the plant. In general, pHs that are around 3 to 5 tend to accumulate more due to their acidic nature versus samples that are 6 and 7 pH. The more alkaline pHs tend to cause more of a precipitation. So instead of it being absorbed by the plant, it gets circulated into the water system and then further into the rivers that were nearby. And so we think that because it's not exposed to as much could have contributed to the effect, as well as we know that the pH in Atlanta in the soil is around 5 to 5.9. And so it kind of balanced between those two things as well. And then lastly, we see figure 6. And so that is the comparison of those soil samples and plant samples. And the important thing to take out of this is the effect of the bioaccumulation. As we said, lead can get absorbed by the soil with plants. And that mainly concentrates in the root system and then will go up through the actual plant into the leaf. The leaf tends to be lower concentrated, but when it comes in direct contact with like water or with the lead itself through the air is when you'll see more of an accumulation. And so what you can see here is that over time, this lead can accumulate in the plant and in the soil, in the actual roots in the main stem of it, which can be thinking of it in terms of a root vegetable. So your carrots or your radishes, when you eat those directly, it goes straight into your body. And there's been studies that show even just 29 nanograms per gram, which equates to 0.029 milligrams per kilogram. That essentially can cause protein synthesis issues, can cause issues with metabolism, as well as just issues with your GI system and being able to absorb the lead and absorb your nutrients properly and cause severe metabolic effects down the line. Additionally, we know with lead exposure, it can cause issues with your bone marrow, your liver, your kidneys, as well as other organ systems. And so we want to make sure that like when you're analyzing your own yard, your own backyard, what is your lead exposure? And we have on our QR slide at the end, QR code, we have a list and some resources to figure out what is your own lead exposure, as well as how to propagate that for yourself. And then lastly, we have figure 7, which shows the concentrations of soil, plant, and then also the blue is from the EPA of their soil analysis. And that was done several years before we came in. And that is just showing you kind of how it was a couple of years prior to we came in versus us. And that could be contributed to a lot of factors. But part of what we want to keep in mind is that there was a study recently done in New York City. And it showed lead has been there for over 100 years. And what they showed is that even though it's been there for a long time, there was still levels that were similar to ours. And that as lead degrades over time, it's still present in the environment. It can still cause problems. And so thank you.
Thank you very much, and we'll have questions here.
So what would you recommend that like the average homeowner do? Because, most people don't really think about the lead content of their soil when they're buying a home.
Yeah, and so there was an incentive started in the Atlanta area through kind of these mini outdoor conferences by Dr. Saikawa, which is one of the contributors to this research. And they conducted soil shops. And these soil shops were to create awareness that, hey, if you bring us a bag of your soil, that we can then in turn analyze it for you to see what your risk factors are. It is a matter of increasing awareness, and especially the homeowner for this property as well. She has created, had articles written about her home and spread around in the population as well. And so that's the factor that kind of has been alluded to in previous talks. It's just a matter of the lack of awareness. And some of the main things that you can at least provide to your patients in future, if they are not able to have their soil analyzed, is try to perform your vegetable or have your vegetable gardens at least 5 to 10 feet from the home. It's theorized that prior to 1978, some of the homes had lead-based paints, and so that would fall into the soil. And so the idea is the further from the house foundation, the safer you will be. And even if your home is newer, it doesn't mean that a home prior to that was built that had that source as well.
Additionally, also, we know that lead exposure is often associated with the environment of where it's at. For example, the house that we got this, the patient came from, she lived right next to the railroad. You could literally see the train going by. And we know in Atlanta, there's a lot of huge railroad system, and that's what tends to cause this propagation. So pretty much starting in the Bronx all the way down to the south. And if you live by areas where there would be those exposures, it's also something to keep in mind. Another thing I wanted to add too is that if you do have a home that does have this exposure, one of the problems is that now you have to disclose that to every home buyer who's about to buy your home. And so that can also cause problems in selling your home and have those financial disabilities as well.
Thank y'all so much.
Please support our mission to improve quality of patient care through education. Join us, follow us, and share this content with family and friends.